Hi, this is Sarah, and I will be showing part A for project 2. So, starting with geometry, I started by going into settings and creating a grid here, as you can see, in 2D and Snap. Um, I then went to draw, and on the XY plane, I used the rectangle tool to create a rectangle, and I gave it dimensions. I gave it a horizontal dimension of 1 meter and a vertical dimension of 0.1 meters. Then I went to concept and I created a surface from a sketch, and that's where you can see that gray body right here. And that was pretty much it for geometry. Then I went to meshing over here, and as you can see, I created 4 meshes. I started with the face mesh. So if I clicked face mesh, I selected this face right here, and I just generated the mesh. Then for the other meshes, for this one, I used the top and bottom edge to create a mesh. I used these 2 edges, I used number of divisions, and I used 50 divisions, and I used hard. For the next one, I used the left edge or the inlet to create a mesh, again, number of divisions, and I used 60 divisions this time, and I still used hard. I also used a bias factor of 70. And then for the final mesh, I did the outlet. I did 60 divisions, hard, and a bias factor of 70, same as the inlet. And I generated all of these. I also named each of the edges. So for the face, I called it airflow. For the left edge, I called it inlet. For the right edge, I called it outlet. For the bottom edge, I named it the plate, and then for the top edge, this isn't technically a plate, so I just called it a boundary field. And that was pretty much it for the mesh and name selections. Then I went to setup over here. So for setup, main things I changed were I made sure that I had a laminar viscosity right here instead of the K omega. For materials, I went to Fluent and I used air. As you can see here, I changed it from 1.228 to 1.2, and then I changed this viscosity to the one shown in the project, 1.8 times 10 to the negative 5. This doesn't change for cell zone conditions. And then for boundary conditions, for the inlet, all I did here, the only thing I changed was I set the velocity to 2 meters per second. And that is a velocity inlet. For the outlet, this is a pressure inlet, and I didn't change anything here, so this is all good. For the wall or the plate, the only thing we want to make sure is that it's stationary and it has no slip condition, which it automatically does. And that's pretty much it. Then I went to initialization, and I used a standard initialization, and I computed from the inlet, and then I initialized it. Then I ran the calculations and I used a million iterations. And then once all that was done, um, you could see the graphs converging. Um, and then after that, I created the contours. So that's the pressure. So for here, for the velocity contours and vectors, I went to contours, I selected the velocity contour, save and display, close, and then under vectors, again, I selected velocity for the vectors, save and display, and now you can see the vectors and contours displayed at the same time. For pressure, all we need is the contour, so I just selected pressure instead of the velocity. And then this is the pressure contour. Now this is total pressure, but in the report as well, I also included the static pressure, which you can see has a different contour, as well as the dynamic pressure, which looks pretty similar to the total pressure. And yeah, that was pretty much it for part A.